So far we were just using one single source file for all our programs written in ABC, and for the beginning that's okay because it's actually simple to understand what is going on. But when the programs grow over time, become more complex, you want to organize things in a better way. You want to split your program into different source files, into different translation units, and in this video I want to show you by example how you can do this. And here I have a toy example. Here we certainly don't have to break it into several translation units, into several source files, but think of this part as some implementation for a complicated algorithm, and this algorithm gets tested here with this function main. So I, for example, would like to have this here in a file, for example, foobar.abc, and this here in a file x for executable, test for testing, and I want to test foobar.abc. And then I think I can better focus. If I want to improve the algorithm, I just have to look into this file. If I want to test something different from before, I just look into the test program. Now also think about the inclusion for this header file. This is just needed actually in the function main, because here we have the printfs. So this actually also goes into this file xtest_foobar.abc. So in a first step, I end up with something like that. Now it might be natural to assume that you now can compile it like that, the name of the compiler, followed by the list of the source files. Maybe in this order. Because then one would assume that the compiler first reads file foobar.abc line by line, then the test program line by line, and then you would basically end up with what you had before, except for the position of this include directive. But this include directive is anyway just needed for the declaration of printf, and printf is not used until here. So it would be okay to have it here. But this is not how it works, and that's the reason why you will get an error message from the compiler. The error message would be that foo is not declared. And the reason for this error message is that the compiler is treating this list of source files differently. It's treating each source file independent of the other source files. That means no matter in which order you specify here, this list of source files, the compiler will try to generate machine code, an object file, from this source file without using this source file. And it also will try to generate an object file, machine code from this source file, without using this source file. The reason for that is a different story. In short, the compiler is not generating executables at all. The compiler is just generating these object files, and some tool afterwards called the linker will link together these object files, which contain machine code for these different source files, for these different translation units. So we have to deal with this fact, how things work, and that means we have to think about a way that this translation unit, this source file, gets declaration for what is provided here. And the pattern for that I want to introduce you here on this slide. What you see here are pure declarations. Declarations are easy to recognize in ABC. They always start with this keyword extern. And declarations are pure bookkeeping informations. For example, the bookkeeping information that foo is an identifier for a variable, not a function, a variable of type int. And this information is needed for the compiler to generate here, for example, correct code when we use foo here, because then the compiler knows how to generate the correct fetch instruction. Also here, the bookkeeping information for bar is that bar is a function which does not accept any arguments and returns a value of type int. And with that, the compiler can generate here the correct function call and pass the return value correctly to printf. So this information is needed for this translation unit, and that's why you have to include this header file with this include directive. If you use in this include directives this double quotes, it tells the compiler to look for this header file in the same directory in which this source file is located. If you use this angles, the compiler will look for this header file in some directory which actually depends on the installation. In my case, it would be somewhere in user local include ABC. So from this here together, the compiler can generate machine code, some object file, which will be called xtest_foobar.o. Let me clean that up. The compiler also will generate from this two an object file for foobar.abc, and this object file will be called foobar.o. And then the linker will link together these object files, so this linker, the tool LD, into an executable, for example, a.out. And actually, it will also link some system libraries. For example, a library which contains the code for printf. Now, it might be strange that we have to include here our own header file, because the bookkeeping information up here is also provided in the source file itself. For example, the bookkeeping information about foo, that it is a variable of type int. This information is also provided here in the definition for this variable. A definition is also a declaration. Also the information that bar is a function, not accepting any arguments, returning a value of type int. This information is also provided here. But first of all, it's good practice to include your own header files. Assume the following. Assume you would change the implementation here of bar into something where bar suddenly becomes a global variable. Because here this function bar anyway just returns the value, so it would be natural that the programmer for foobar.abc changes its mind and turns this into global bar int with value 13. Then if you don't keep this here in sync, you would get an error from the compiler that bar was previously declared as a function and now it's a variable, so you get an error message from the compiler, which is a good thing, because if you would not get an error message, the creation of machine code for this source file would be incorrect, because here we have to know whether bar is actually in the end a function call or just a fetch instruction. In C or C++, you're actually not required to include your own header file. You simply would get undefined behavior. You will see that if you would leave out this line, this include directive, however, you get in ABC an error. Not from the compiler will still generate just from that some machine code, but a machine code which is not suitable for the linker to link together these object files. So in the error message, you will see that LD complains about something. We will deal with the technical background later when we do things on a lower level, when we do assembly programming. But for now, this is the pattern that you always include your own header file if you provide functions or global variables to other translation units. First of all, for good practice. Second of all, otherwise you will not get an executable. Now some typical use case. Think of a project where one programmer is working on this source file and another programmer on this source file for checking, testing, using the functionality provided in foobar. And they agreed on this header file, which basically declares what functionality foobar is providing, and this header file is also used by this xtest source file. So same case as before. And then the software grows and then people come up with ideas like it would be better to have some additional function in my source file, a function, let's call it dummy. And the other person also comes up with the idea that it would be better to outsource certain things into an extra function, and also comes up with the same name. And then it's interesting to know whether you do have a name conflict, because you have two functions with the same name, actually even with the same signature. They both do not accept any arguments, do not return a value. And this is not the case. This perfectly compiles and you can run the program. As long as this function dummy is not declared in the header file, because then these functions are internal functions to these translation units. If, however, function dummy would have been declared as external in the header file, and both of these source files do include this header file, and both of these source files do implement such a function, then you get a problem. If you agree on a function in the header file to be external, then only one of these translation units is allowed to implement it, and otherwise you get an error from the linker. So this is basically the recipe for breaking source files into translation units and make it work. And this we now will apply in the next exercise to our Lexer for the compiler project. And here it certainly makes sense to break this into parts, into an implementation for the Lexer, an interface for the Lexer, so that we later can change the implementation of the Lexer, improve it. That means we will recognize more tokens. That means we change something here. We change something in the implementation here. We add new features, for example, keeping track of line numbers, stuff like that. And then you want to test this Lexer, but you also want to use it. So there also will be something like parser.abc, which will include this header file and make use of the Lexer. And with that, we will deal in the next exercise.